Morning, everyone. My name is Victor Monga. I am on the board of Cloud Security Alliance. Today we have an event and it's a webinar since we couldn't meet in person. So we thought, why don't we use it for virtual events? We wanted to start with the welcome message, and we want to tell you what Cloud Security Alliance is and what we do at this chapter, in LA chapter. So we have started this chapter 10 years ago, and we have come a long way where we have provided webinars, seminars, summits, conferences, and currently during this time, we are switching all of our events to virtual events. On the screen, you can see chapter leadership. Chris Rides is our president serving this term. I'm serving as vice president. We have Kenny, our treasurer, Aryan, Anil, Chad. They are our board members as well. This session will be recorded, and you can find the slides on LinkedIn, csala.org. Also, you can follow us on Twitter. We provide notification about events. We provide notification about past events and recordings on Twitter as well. This recording will be available at youtube.csala.org. This year, we have provided and conducted a few of the sessions. In January, we had talked about incident response in AWS. Then in January, we also attended AppSec Cali, where we met our members. Always good to see our members during conferences. In January, we also talked about network security monitoring. It's a free tool called Pro, and we provided the introduction to Pro. We're also going to continue providing some hands-on workshops on Pro as well. Then we started talking about API security, since that's becoming a thing in our industry, technical industry. So we had provided API security part 1. We have another session coming up in a few weeks that will go deep into API security. People who attended RSA and CSA Summit, thank you. We had a lot of fun, a lot of drinking. We will also post all the slides and sessions from RSA to our LinkedIn, Twitter, and YouTube. In March, we have started with the Shodan. People who don't know Shodan, it's I call it a Google of all the IoTs. So the way we use Google for any text-based or anything we want to search for, Shodan is for all the IoTs, webcams. You can see anything going on in the entire world if it has a public IP and it's exposed to internet, and services are listening on that IP. Then in March, we also had the API security part 2. And today here we are with Jason from Turn Micro. We're going to talk about security for DevSecOps or DevOps. I think he's going to correct me for that. DevOps for CI/CD pipeline. Thank you to our Trend Micro partner. They signed up for an entire year, and they are supporting our chapter. It means a lot because we are a nonprofit organization. We need to have funding to keep us operating as well. Thank you, Trend Micro, for that. We have our community partners. So most of our members have access to Tyro Security. If you would like to have a resume reviewed, if you would like to have a job advice or anything. We have Virtual Testing Foundation. They are our online education partner. So all the online webinars, all the online education we provide at Cloud Security Alliance is partnered with Virtual Testing Foundation. And next, on April 2nd, we are partnering with a virtual summit by Data Connectors. We have Dave, their leader, conference leader, here on the call as well. If anyone has specific questions about this conference, we'll post the link in our YouTube, LinkedIn, and Twitter. We'll also post the link in our meetup. So if you'd like to get a good conference, virtual conference attended on April 2nd, please go ahead and register for it. Dave, do you want to give 2 minutes introduction to your conference?
Sure. Thank you all for your support. You guys have been great in past conferences we've done. Really appreciate it. We like being one of your partners too. This pass gives you confidential registration. But if you do visit someone's booth and give them the right to have your email, they can contact you. But otherwise, all of your information is kept confidential. And we did have a change of the keynote speakers this morning. We will have Michael Husnick, the head of protected intelligence for Facebook. And then CISA backed out in deference to, we have the assistant director, the #2 guy at the US Secret Service will be presenting. So this should be a good event. We're sold out. It's going to be live. You can do Q&A via chat to both of the keynotes. And we are also presenting a virtual exhibit for CSA. And we look to have that up and running so you can have materials, videos, instructionals on your site. You can even you can man the booth if you want, and people can chat with you about your organization. So, and if you have any questions, I am happy to answer them throughout today or the weekend. And Victor has all my contact info.
Awesome. Thank you, Dave. All right.
Thanks, guys.
With that, let's begin our show. Mr. Jason from Trend Micro.
Excellent. Thank you, Victor. Appreciate the introduction. Just so you guys, maybe just a little level set here in terms of how this all works. Normally I like, the crowd interaction and people, shouting their questions from the audience. Certainly with this virtual environment, you can't do that so much, but we do have both a chat and a questions and answers. If you have across the bottom, you should see both of those as well. So go ahead and type your questions in there. Happy to help. There was one about the link to the registration for on that previous slide. Certainly, I think Victor and team will send out all the information about the registration and links, as well as this entire presentation will be made available as well after as well. So with that being said, I had the wonderful chance to talk to some of you in Santa Monica back in February with I would say a similar title, but if you attended that, no worries. We have brand new content here as well. So this isn't a duplicate of that presentation. I have entirely new content here. I do like to reuse the same titles because sometimes I'm only marginally creative. So I thought this one was one of my better ones. So use this as much as I can for my different presentations as well. So with that, thank you all for taking some time today, and for those listening on a recorded session in the future, hello from the past, and thank you so much for taking the time to listen to this webinar as well. So my name is Jason Davlo. I'm a cloud security advisor. My contact information here is on the screen. I love to make connections on LinkedIn. It is my main social sharing platform, so I do share a lot of threat intelligence content about security industry as a whole, and really try to provide the followers of that with some kind of pertinent information and news and things that are happening all along the security space. So I've been in the security space for over 20 years. I've been focused on container security for the last 5 or so. Really spent the last 3+ years talking about DevOps and really hearing how teams, I would say, are struggling for the most part in terms of either implementing security within DevOps processes or security teams struggling with making that connection to developers. It's really what this talk is focused on. It is, I'd say, a bit of a 100 level talk, at least to the start, but certainly I can go as deep as you would like in terms of technical questions. So feel free to, if you want some more expansion on some topics, we can certainly do that as well. One of my biggest things is also helping people. I am, that guy, high emotional EQ person. So I do enjoy really helping people and really helping them along whatever journey they're on, particularly in this space, talking about cloud security or overall security in general. So to start, I'm just going to kind of level set about DevOps, kind of what it is. I know probably you guys have heard this a lot, not just maybe DevOps, but DevSecOps and things like that as well. I'm going to just throw out some concepts here, just kind of level set, and then we'll kind of get into the security bits towards the end. This is also part of a 5-part webinar, so I'll be expanding with some hands-on demos later this year on different technologies, so you can really get your hands on different technology focuses and really play with the technology that I'll be talking about today. But ultimately, it's up to you to really extend that olive branch for those of you in security engineer positions or InfoSec teams to really reach out to the development teams, and that's really kind of the focus of this talk. I think a lot of people, I should say, that I'm making a little bit of assumption, but most people have probably seen this infinity loop here, which represents the continuous integration, collaboration, testing, deployment, and making sure that all of these pieces are continuously done. It's all about having feedback at each step. So that continuous feedback in the middle is super important. So each kind of step or stage that you take along this journey, we want to make sure that we have that feedback so you can continually improve not just the process, but the technology or value you're delivering to customers along this journey as well. Gartner and others have an interesting kind of description when it comes to DevOps. I really like this change in IT culture. If anyone has read the book, The Phoenix Project, it's all about that kind of change. They just released a new book, I believe, just a couple months ago called The Unicorn Project, same author and same kind of problems that they've, it's the next stage, I would say, of that business transformation as they've incorporated DevOps processes throughout the business. Really interesting book, and if someone hasn't had the chance to read it, it's actually gives you a really good perception of this change in IT culture and really how businesses need to really come together to all back this DevOps transformation in terms for it to be successful within a particular environment. So rewinding time a little bit here, when we had both developers or operations, and maybe we're not rewinding time at all. This could be how your current business is organized today. With developers and operations as separate teams, they each have kind of their, I would say their specific focus of duties of what they're trying to do. So on the left side, or the development tree, they're responsible for that product, right? So the product or software that they're building, your company is building to establish either internal organization needs or external to help sell this piece of software into the business. Your developers are frontline in terms of creating that product that you're delivering, or the infrastructure to essentially the back-end software that allows your business to continually run. Whereas operation teams are really focused on the operations of that software. So perhaps the infrastructure or managing your tool sets or the servers that are in use. And really here, the one at the bottom, which also carries into security as well, is making sure that you have that availability. So again, you have that 3 pillars of security, CIA, A being availability, and really oftentimes overlooked by security teams. We want to make sure that we bring that back in, and as it is, in terms of operations, that's their biggest focus here as well. But what happens is you have all of these teams doing separate functions here, both with developers as well as operations, and the dollars that are associated with having people being very specialized in each of these as well. In terms of tool sets, you have separate tool sets here that developers would use, as well as ones with the operations or infrastructure team might use as well. But the nice thing about these tools is they can actually be interchanged, where operations teams might be using things like Docker within their environments to making sure that things are launching in containers. They might be also interested or using that tool within their space. And developers might be writing code for Chef, like cookbooks, or infrastructure as code within AWS or GCP. So there is some kind of interoperability between the tool sets that these two teams would be using. But what we've seen is virtualization is, everywhere, as we all know. There is definitely some pros and cons when you're talking about virtual machines. So certainly, when you're comparing them to physical servers, having a virtual machine that can run multiple operating systems or multiple applications on a single piece of hardware is one of the nice pieces about virtualization. You get more return of investment on the hardware that you've already used. That technical debt that you used to purchase hardware can now be spread a little bit better in terms of not just having one physical server for one application, but with virtualization, you allow that to spread multiple ways. There's certainly cons here as well. As we've looked at, and as I'll dive in further with this presentation, you'll see that with the adoption of container technology, there's a lot of overhead even with virtual machines that we can actually save by moving platforms as well. So again, the dollar comes in here in terms of that technical debt that we've made in terms of investment. But let's see if we can kind of improve that even more. So here's a typical architecture, and it's going to be a theme of not just this webinar, but multiple ones to follow in the coming months, is really looking at different architectures and really how to architect the security within these different architectures as well. So for this example, you would notice that you would have VMware that your ops or infrastructure team is managing. You can click deploy templates and basically watch and monitor the resource usage within a virtualized environment. That's one of the great things about VMware is it gives you consolidation of tool sets, like monitoring or the software-defined networking or the hypervisor space, a lot of consolidation of that to visibility, so less and less team members have to actually watch or be involved into that process. So when you're talking about big development teams, they need something also to say consolidate what the operations teams were doing in terms of consolidating physical machines into virtualization. How do big development teams consolidate their code into manageable pieces as well? So in this example here, you're bringing in tools like a code repository, typically known as a Git Repo. You have GitHub on the left, and GitLabs on the right, the Fox. So these two icons are typically used in terms of software for Git repos. A Git repo is just really where the code is committed that the developers are creating. So they're writing the source code, and then they commit it, and now you have a version tracked change of that source. So you can quickly say move backwards or forwards, but everything is kept aligned with all of the changes that are made, what the changes are. And then from that code repository, you would have a builder in the old days. So a person of the development team would then take those committed code changes and build them into an application, and then either install that application into a virtual machine that the operations team provided, or in some, they might also say deploy the virtual machine as well, but not in this instance where these teams are completely separate. You would have just the code builder throwing the code over the fence once the application is built directly to the operations team to then build that onto a virtual machine. But there's a few problems with this type of design where you have kind of everyone throwing stuff over. So if, say, something breaks in the test environment, the VM team or the application team sees that that's a problem, and maybe it's a problem with a configuration on the operation side, so a firewall rule or something similar. Or the operations team seeing applications try to request way more resources than what they initially requested, and now they're throwing back to say, hey, why is your application running so out of control? So when you have people on both sides, you end up having more features to actually handle for each one of those people. So each person on the development side would have features that they need to have and take control of. Each one of these features, you might introduce more bugs into that cycle. The bugs that are introduced now take additional time to figure out because, again, you have that separation of teams. This downtime results in less money, and less money equals lower growth for that business. So ultimately what we're trying to achieve here is making sure that we accelerate that value that we're delivering to the customers through this DevOps processes. And let's see how we can start achieving that here. We see a lot of shift left or shifting security left, everything is shifting left. What that means is if you think back to that infinity loop, all of the build and code committing stuff that the developers do is all on that left-hand side. So to put it kind of graphically, you have, as you move security or move things closer to the development process, so closer to the code, you actually eliminate, or not eliminate, but you lower both the cost and time required to find and identify problems. There was some research done last year that said on the right-hand side, finding and fixing something in production is 40 times the cost as it was if you had fixed it in the development stages. Because it could be just a line of code or a comma that was left in that now makes it vulnerable, and perhaps now you have open vulnerabilities within this application that are now being exploited. And the tools, the cost associated with production or runtime tools is much greater than, say, a developer using, removing that language or doing some unit tests or things like that. So with that being said, the earlier that you can find problems, you actually are creating value within your pipelines without actually having to, say, deploy or run different types of technologies as well. So now what we have here is an example of a continuous integration, continuous deployment or delivery tool set. At the top here, that waiter, he's known as Jenkins. And what he's responsible for is really taking those code commits, building that into the application, and then delivering it into a production environment or a test environment. It can also handle things like making sure that the test is all automated, as well as the notifications back to developers. So you have this overarching software delivery lifecycle management tool that allows you to give your developers visibility across both the development pipeline as well as the deployment pipeline, and making sure that the VMs are reacting as development is expecting to, and really automating also that delivery, deployment, testing, as well as the notification back into that feed as well. A question came in on the 40x cost to fix bug in production. I'll double check. I thought it was Gartner, but I will look up. I have the reference on another slide deck, and I'll be sure to share that after with that as well. So I appreciate that question. Thank you. So what we are finding is, despite this continuous integration software and the ability to basically start automating some of the practices, what we still have is this giant VM, I'll call it, looming here. We're still using a lot of resources that are unused in a virtualized environment. And this is due to that guest operating system that exists within within this platform, right? So while you can divvy up the hardware requirements within each individual virtual machine, so each one can have a sliver of that hardware of the physical hardware, you still have that guest OS on each VM that takes up a considerable amount of resources just to run the operating system itself. So while containers have been around for quite some time, longer than, I think, 20, 30 years, part of a Linux subsystem for quite some time, they've grown in popularity today for one key reason. And that reason is it eliminates that guest OS from each individual image and allows developers really to just focus on the microservices of their particular application. If you think of it like a puzzle, and each developer basically gets a little corner that will automatically work and connect to all the other pieces without having to, say, reach over each other. Each person has a little piece of the puzzle in front of them. They fix just the microservice, and then they all communicate seamlessly without actually having to adjust the entire monolith. At Trend Micro, we have an internal program here called Break Up the Monolith. One of our pieces of software is a monolithic design, but it is protecting container environments today. But what we're trying to do is actually break up that application into smaller pieces, a containerized platform, so we can actually unify and help accelerate the customer's experience in terms of installation and usability. Because if we need to, say, add some new features or functionality to a specific piece, we only need to make a change to that particular piece instead of making a change to the overall giant piece of software. If you look at, say, something on the left, if you're trying to make a change to, and this basically represents a monolithic application, if you tried to make changes or increase the capacity of some of the things, you would end up impacting other pieces within it because it no longer fits in a way that the original software was designed to run. So this is really where the containers allow us to build faster, because you're eliminating a lot of the dependencies required to actually run the application that would typically be stored in the guest operating system of a VM, and allows you really to focus on just building the applications and the libraries associated with them and package them in a nice little compact space that then fits and can run anywhere within that environment as well. So here's a couple examples of why containers are important down below. So things like being portable or scalable, you can move them. You have, they can run on any type of environment that shares the same operating system. You have the ability to make them interchangeable. They're super lightweight. They can speed up deployments and really easy to configure and use as well. Here's some of the stats that we've seen in terms of how Docker, which is a container platform, how Docker and what it can do for your business. So some stats here. This is taken specifically from Docker, so they could be a little biased, of course. But overall, you're looking at tremendous increases in performance and acceleration of delivery, as well as resource utilization goes down as well. So you can really make sure that you can continue to use and get a better return of investment on that hardware that you've already purchased. Of course, this still runs in on-premise hardware environments. You can have virtualized container environments as well. So a container system running on a VM, which can also help accelerate your business and give you that return of investment on that hardware purchase as well. So as I mentioned, this is the difference between VMs and containers. You have the, essentially on the left, you have your virtual machines, and you can see that the largest piece of this is that guest operating system, because you have resources in use to really making sure that the operating system that exists on each one of the virtual machines has to all be there, has to be patched, has to include all of the things that make a system run, as well as all the dependencies, the libraries, and things like that as well. Whereas in containers, you're actually putting that the operating system onto the host and using that. So a Linux host can run Linux containers because they all share very similar design in terms of the kernel and what the kernel is able to accomplish from the operating system. You can eliminate all of those dependencies from the containers themselves. So again, the containers become super lightweight and very agile in terms of focusing the development effort just on the bins and libraries that you need, and then building your application on top of that. So for a step-by-step to create a VM, you would go through these steps, install the operating system, apply all your patches, install the libraries that are required for your application. Maybe this is SQL Server or IIS or some other type of framework in a Windows environment. You would have the same thing in a Linux environment, so libraries that the application needs to use, as well as the dependencies. You would then install your applications. It could be several, it could be one, depending on how focused your application is. In terms of a monolithic app, it's probably just the single app on a single VM. You would then create that gold image, and then you would deploy that VM from the image, and now you have a running virtual machine based on the application that you would like to run within the environment. But in terms of updating that, you would have to break or essentially deploy a VM, make all the changes that you would like, and then create a new gold image from that, and then shut it down and delete the old ones. A little bit of an arduous process there in terms of making sure that your VMs are constantly updated with patches as they're coming out and things like that as well. When you're talking about a step-by-step to create a container, and for those of you that want to go a little more technical, I do have some examples here of a Docker file in the coming slides as well. So you write this Docker file, which is essentially it's like an instructions on how to build it, but they're a few words of code that basically then executes into something that happens. You would then build the Docker image from that Docker file, which is then stored in a registry. Think of a registry as just an inventory of all your images prior to them launching into deployment. So it's just a way to kind of catalog the different container images that you've built. And then finally, you would deploy that Docker container from the image. And again, because you don't have to worry about operating systems or dependencies or installing patches, that could just go and start running immediately there. So Docker images, they're layer-based. So every Docker file line creates a layer. So think of it like, I don't know, like an onion example. That's the first one that popped into my mind. I apologize, but as you write one line, you have a specific layer that gets added to a container. These layers could also be other containers. So you could pull in a container infrastructure inside a base layer as well. This is done a lot of times. So in terms of like open source, maybe you're bringing in just one particular container, but that container also has 10 other dependencies, which it then brings in. So you could have 10 lines of code turning into 4,000 based on the dependencies as well. So you can get really specific in terms of these layers and the dependencies, but really making sure that these layers, in terms of as they're developed and deployed, all fit within each other to actually run this application within the container. So here's kind of an example here. So you have a container layer that is read-write, and then each of the image layers might have some type of technology that it's bringing in, maybe a library, maybe an application that's being installed, all built again on a singular operating system that the container host is running. So this is where I mentioned that you can also bring in other Dockers as layers. So you can really continue to embed more and more images inside a container platform that allows you really the infinite flexibility, as well as the ease of use. So you don't have to recreate the rule, recreate the wheel in terms of, well, I need a Apache web server. Am I going to go and install it all through the Docker file, or let me just pull in an Apache container that already does all of those dependencies as well? So it allows you very quickly, again, to do some code reuse specifically from public registries to allow you to really get up and running very, very quickly as well. Here's a kind of a graphical explanation of that as well. So each one of the image layers might call a specific file, and then it all gets essentially compiled as a top layer once the image is built, that then allows access to all of the different files, libraries, dependencies, applications that you built at each layer. And for a more visual, for me, I'm super visual, so this slide really works for me as well. So essentially you have that top level, you're bringing in the languages that you need, and then you're bringing in the applications that are supported by those languages as well. So here's a sample Docker file. So for the base image at the very top, you would say, well, I need a node image, so let's pull node 11. So now node 11 is on that first layer, and now you're defining the user for that particular install of node. You would then, here on the next layer, you have it making a directory as a working directory, and then installing the one of the dependencies, Axios, copying that to your app. So you're copying just basically your app directory into the working directory, which is your node/app, and then you're creating the project, and now you have a running node application with its dependency already loaded, and this can be then sent to deployment. It will automatically deploy and run your project and automatically load the dependencies needed to make this container work successfully. Here's a little bit more into the architecture on what are the different components and how they work. So you would have, say, on the client side, you would say implement a Docker build first. Docker build will basically take the code from your Git repo and then push it into the Docker daemon to actually build that container image. That build then gets pulled the build goes to the images that are on the Docker host. So now that image is available in both the registry and the host. Next, you would do a pull request for additional things you might need from your registry. Remember, the registry is like your container images, the catalog of what you're looking for. In this case, we'll pull another image into the Docker host for running as well. And then finally, we'll execute the Docker run command, which allows that image to then run inside the container environment. So this is pretty simplified, but you would also, as a client, not necessarily do those things on the left, like type them into a console. Your pipeline managers, your CI/CD tool like Jenkins, Travis, Circle CI, whatever that pipeline manager looks like in terms of your CI/CD tooling, that would actually run all of that for you and basically be that manager of this particular deployment. You might also be exploring or utilizing things like Kubernetes, which can also take over the operational aspects of Docker containers, so that all of the client commands might also be coming from Kubernetes and launching those accordingly as well. So this represents really that biggest difference between virtual machines and containers, and making sure that, again, we're really maximizing the resources that are available within these particular hosts and allowing the most resources available so you can actually run more containers, be more agile, be more flexible in terms of what that container environment allows you to be, but ultimately saving you that resource cost from all of those different guest OS running in a normal operating system within a virtual machine. So now what this looks like in terms of architecture is your developers, again, are pushing their code changes into the code repository. You have Jenkins there as before, that's actually building the container images from the code repository. And now it has that extra step of storing those in the container image repository. So that it can then pull from this catalog based on a developer's action as part of that pipeline. They want to push it into production or push it into a deployment stage. which then Jenkins can do directly and really take over the operational side of deploying that application that typically the operations team would have to do in the previous models. So this really allows us, again, to integrate the developer and operations experience by using a CI/CD tool set like Jenkins. And again, building in containers, again, gives you that flexibility over the resources and use over a traditional virtualized environment. So when we're talking about Docker Hub, this is really where it comes in with that public registries. And as I mentioned, in terms of ease of use from a developer's experience, a developer might not want to build out all of the, in my use case or example was Apache. So they might not want to do the install of Apache, find the dependencies, place all of the dependencies so that Apache can run. That's already been done many, many times in terms of at Docker Hub. So Docker Hub's a public repository of a number of images. Some are company supported, so you might find some Trend Micro containers sitting there. Some are just like one person just helping out the community by building or implementing several different technologies into a single container. But it tends to be the biggest base in terms of where people are building from to save them time, as well as to allow them to be more agile, so they have to spend time, much like the building of a VM, going through each one of those steps of building the dependencies, the libraries, the operating system. You could just bring in a container where all the work has been done for you. The problem with this is that even though it is the largest public repository, it's very difficult for people to check every single container image and making sure that all of them are free from different threats. As you can imagine, there's a number of, say, either vulnerable container images that contains vulnerable applications sitting within this repo. There's also a number of ones that have been maliciously targeted to almost like a social engineering trick where you're like, hey, use this build for Apache plus this, they'll save you lots of time. But the threat actor has also included something like coin mining software. And these tend to stay up for quite some time as well. So there was an announcement when I was at DockerCon a few years back. The week of DockerCon, they were talking about Docker Hub images that have been downloaded millions of times that had coin mining software. They were all part of the top 10 most downloaded, and they each had a number of threats and vulnerabilities within them. So the problem is that this is an easy way for developers to bring in these applications, saving them lots of time. But there's no guarantee that the things found on Docker Hub are actually free from different types of threats. So this is really where security comes into play. And now we'll kind of adjust and start talking about really security and how it's integrated into these processes that we just defined. So there's a State of DevOps report that's released every year. Super cool. You can get access to it just by Googling it, free download. It's not anything that's paid for or things like that as well. But we see that highly evolved organizations are 24 times more likely to automate their security policy configurations. And what this just shows is that as you start automating your security policies within these types of environments, you can actually accelerate the value that you're delivering to customers as well. Because again, if you think back to that pyramid of cost as it shifts from left to right, as you move your security into the left-hand side, you're saving time and money. And again, that represents more value that you can focus on to deliver to that customer as well. Snyk also has a State of Open Source Security report. So Snyk is responsible for really making sure that open source scanning is done within environments. So they see that for the top 10 most popular Docker images, So the ones downloaded the most from Docker Hub or other places, they have at least 30 vulnerable system libraries. And while that might not seem like a lot, those are 30 actual holes in your application that now attackers can basically find and move their way through. 44% of Docker images can fix known vulnerabilities just by updating their base image tag. When you think of that base image tag, if you think back to that Docker file I showed that was running node 11, many of these Docker images have, say, node 12 or something similar, where you can basically update the base image just by changing that 11 to 12. You're now on the latest base image tag, and you've also solved 44% of those vulnerabilities just by changing one number within your Docker file. You also, 78% of vulnerabilities are found with indirect dependencies. So if you had an application that had, say, one dependency, that dependency you would have loaded within the container. But as part of that dependency install, an indirect dependency would be when that dependency also requires 3 other things as well. So 3 other dependencies based on that one dependency for your application has now turned into multiple vulnerabilities that are found based on those dependencies or dependencies of dependencies. That sounded really funny, dependencies of dependencies. I don't think I've ever said that word so many times.
Yeah, that was tongue twister.
So the automation and integration by performance profile, really you have the ability here to, as you automate more and more of your security, so not just automating, say, your deployment or delivery using a CI/CD tool set, but also using that to automate your security tests and automate those as well, you start getting into a higher level of elite customers in terms of their performance increase within these types of environments as well. So what we don't want is the developer trees or the DevOps folks creating all of this wonderful content and value, leaving security teams just sitting around with a shovel and reacting to what's happening within this environment, right? So this needs to be a collaboration in terms of, again, throwing something over the fence, creating all this magical stuff in terms of all of these great features and functionality that DevOps teams are creating. We need those 2 teams to work together and making sure that we're delivering that value to customers together. And here's how we can do it. So you might be doing some of this stuff today. I would be shocked if you had a DevOps pipeline and weren't doing any of these things. Please do not put that in the chat. I don't want to know that. But we'll go through some different examples in terms of security tools. And again, I'll just cover these in kind of a high-level statement, but each one of these tool sets we will be investigating in later webinars throughout this year as part of this 5-part webinar series. So if you look back at this architecture again, in terms of how we're deploying containers within our environment, you have different sets of things that are happening today in terms of the developments and what they're creating, how they're using it, how they're pushing it into container registries, and also how they're deploying it into test and production environments. I feel bad for the little security team in the SIM on the right because there's no data flowing to them yet. And this is a really kind of key point here as well. So if you have teams that are already doing this in a cloud environment, and I've touched on this with other presentations if you've caught any of those, is that if you say take a shadow IT DevOps team where they're taking their credit card or the BU of whatever company that they're a part of, that specific BU places their credit card for some cloud spend to really accelerate the development and the deployment of this value that they're trying to give customers. If they're doing all of this to hide their actions and really accelerate it, they're spinning up all this stuff in a cloud environment and doing so in an agile method, and again, delivering that value to customers. There's no possible way that they're going to take all of that stuff that they're doing and then shove it back into an on-premise data center security team so InfoSec can view it and tell them to slow down and stop doing that. So the really that challenge comes between if they're going to not do that, because again, there's no way that they're going to forklift all their data flow and send it back on premise for, and then going through the traditional, say, corporate governments or security teams. Well, some people do in terms of making sure that that's okay. What really needs to happen is the security team needs to be really integrated with this process, so the security team can get the information that they need, while also empowering themselves to deliver the security posture that developers need in terms of really shifting that cost structure left. I've touched on it a couple times now. The earlier that you can fix these security problems in the development cycle, the more money you're saving, as well as the more value that you can then deliver to customers. So with that being said, development teams are typically going to use a bunch of, say, code development tools that they will use to, I would say, the first line of defense. And these tools might not necessarily be of interest in terms of a security team right away, but it's essentially, it would be tool sets that they're using today to really making sure that they have, say, code cleanliness or doing some analysis on their code writing abilities. First and foremost would be unit testing against their source code, making sure that, say, the commas are all there, the parameters are all hung, they're all a part of their software delivery management tools. There's tons out there, but this would be integrated within those types of tool sets to give you that ability there. You would then have static code analysis or software testing, as it's noted here, as well as its brother, dynamic code analysis or software testing. So this is actually looking at the logic of what your application is doing, either at a static or as the code is being, after it's compiled and ran. So these two methodologies allows you to essentially look at your application logic and making sure that the development team aren't introducing things like SQL injection by not doing the proper logic within it as well. And then finally, you have dependency scanning here, which is looking at all of those dependencies for vulnerabilities as they're bringing in within an environment. I mentioned Sneak earlier. They're probably the leaders in this space in terms of dependency scanning and making sure that as the different open source dependencies that you're bringing in as part of your application design, that they're all free from vulnerabilities, again, to making sure we're closing that attack hole correctly. Another interesting thing here is now container scanning, and this really is where security teams come into play. Because you're not affecting any of the build pipeline with a container scanner that's facing the container image repository itself, this really just is a start to give security teams visibility into those container images and basically allowing them to get visibility into vulnerabilities to malware and things like that as well. Thank you, Victor, for the time check. This is my last slide, so should be able to accomplish that. The other piece of container scanning is actually going directly within the build pipeline. So the build pipeline allows us essentially to say, hey, the developer is building something with a vulnerability in it. Instead of letting that run and then say, having some runtime tools say, hey, this has a vulnerability that we're blocking. Instead, you can actually use this technology to fail the build back to a developer to allow them to, again, fix that vulnerability earlier on the cycle, instead of having security, turn all red in the face and come barging into the, the developer's room and start screaming about vulnerabilities. So this helps push the security onus back into the development platform, again, to fix that sooner within that pipeline. You would then have some runtime protection within your environment. In this case, something protecting the Docker engines within your environment. So there's a number of tools out there that's either walls around something that allows you not to do it, or agent of some sort that's allowing you inspection into that as well. And then here's, you might also introduce maybe some privileged container security that's looking at other containers as well. And then finally, you'll have all of this data being pushed into a SIEM and the notification channel of Slack here, but it could be other things as well. Basically keeping everyone up to date and notifying both the development stack and the security team. Another technology at the top, which is really interesting, the RASP, Runtime Application Self-Protection, is the ability to actually wrap security around the application itself. So I know you're doing some API security webinars and meetings in last week and the weeks coming up as well around API security. More likely than not, they'll be talking about RASP type technologies as well, because certainly those are the prime example of how you can really secure those types of information. You know, I do work at Trend Micro, so this is an overlay of the security solutions that we offer within this space. Again, in the coming webinars, I'll talk about these different architectures and technologies on what that looks like from a security point of view and how to really integrate them into the different architectures that you might see within your environments. And we do offer a collection of security services through a single portal. So based on your appetite of these security services, you have the ability to, again, utilize a single place to, similar to like a marketplace on a cloud platform, on creating and clicking and using the security services needed to really protect the different cloud priorities that you might have within this environment. I always like to end with a smile. Dilbert's one of my favorites. So just kind of a funny little comic here in terms of you can't always throw just new technology at a problem. It's all about that partnership between individuals, between different BUs. We're all people in this space, and we all need to making sure that we really help each other ultimately create the most value for the customers that we can, whether it's through separate development and operations and security teams, but ultimately we want to drive towards that DevOps model where essentially security is integrated directly within all the processes that you have within your particular environments. With that being said, again, I love connecting with people on LinkedIn, so feel free to reach out. I wish we could have done this in person, but I'll be seeing hopefully all of you at the next in-person meeting once that happens, and hopefully in the very near future. I don't see any open questions here, but certainly reach out to me. This content will all be shared. I also have some learning content that I'll send to Victor just to get approval that we can share as a follow-up as well. So certainly welcome the thing there. There was one request for slides. Yes, I'll get that. We do have a promo. It's not a promo. We're not selling anything for this deal, but we are offering our home license for free 6 months for any teleworkers as well. I'll be sure to send that link as well to the audience via the meetup group or through the social channels. Mine's on there as well, so we have shared that as well. So it's not a sales pitch or anything like that. We're just trying to do our part in terms of helping this global pandemic and stepping in where Trend Micro usually does. And it's why I've been an employee of the company for nearly 20 years, is they're super social responsible and really aligned in the giving back to global communities as well as local communities in each of the 75 countries I think we're in worldwide. So again, thank you so much for your time today. And I'll just throw it over to Victor just for closing. But again, thank you so much, and feel free to reach out if I can help with any data after.
Oh, thank you, Jason. I'm actually standing and applauding as we speak. So thanks so much. It was well received. It was well delivered. As I said, you said we don't have any open questions that we need to answer right now, but any of the attendees that would like to get in touch with us or Jason, you can reach out to us, contact@csala.org. We're very active on social media these days, so you can follow us at LinkedIn, Twitter. We have a YouTube channel, so all of this will be recorded and will be posted on YouTube, and slides will be shared on LinkedIn. Again, thank you so much, Jason. Thanks for all the work you did.
Yep, thank you, everybody. Appreciate it.